Wykoff, retina specialist from Houston, Texas.
Hi, tell us about what you presented here at AAO 2019.
You know, the field of macular degeneration it's really exciting now, right? It's important to consider wet macular degeneration and dry macular degeneration separately. And in the field of wet macular degeneration, fortunately for a decade plus now, we've had great therapeutics. But the therapeutics are only getting better, and there's two ways they're getting better: durability and efficacy, and both those are sort of critical to consider independently. The data that I presented here at AAO 2019 was a new molecule, a new class of molecules really, called ABCs, or antibody biopolymer conjugates. And it's really a drug delivery platform for delivering medicines into the eye with a long durability profile. The concept with these ABCs is to take a specific antibody and bind it to a intentionally high molecular weight, optically clear phosphorylcholine biopolymer to create an antibody biopolymer conjugate that's stable because there's a single site-specific covalent linkage between the antibody and the biopolymer. And these biopolymers have been engineered to critically be optically clear, so they're large. So KSI-301 is the name of the anti-VEGF ABC that now has been studied in 113 patients to date and has already entered a pivotal phase 2 trial in wet AMD. But the data we presented today was based on the phase 1B work, which was a trial specifically designed to look at durability of this molecule. And again, just to back up, KSI-301 is an ABC that leverages two components to try to increase durability. One is size. Because of the phosphorylcholine biopolymer, KSI-301 is about 950 kilodaltons. And if you put that in context of an antibody, which is somewhere about 100 or slightly larger than 100 kilodaltons, the KSI-301 is a much larger molecule. And therefore that should translate into a longer ocular residence time after injection, the hope being that you see a significant durability signal because of that. Additionally, KSI-301 has a 3.5-fold greater molar VEGF binding capacity than aflibercept, and the estimation is therefore that it should have a much longer biological effect inside the eye. And in animal models, this appears to be the case. It has very good tissue penetration into the retina. It has a nice durability signal in animals, and then critically, once it diffuses into systemic circulation, it has a short half-life outside of the eye. In other words, it's cleared quickly, which is sort of the ideal principles after injecting a molecule into the eye. You want it to stay in the eye a long time, do what it's supposed to do, and then once it leaves the eye, you want it to leave the body quickly. And that's what the animal models have shown. And so the question is, well, what does the human data look like? And so it's been studied in two phase 1 programs. A phase 1A program looked at 9 eyes with DME incompletely responsive to anti-VEGF therapies and found that a single injection of KSI-301 was well tolerated and appeared to have a good durability signal, but it was just one injection in 9 patients. And so the phase 1B program was a really important study, and that trial looked at wet AMD eyes, DME eyes, and RVO eyes, 35 eyes each for 105 total patients. And those patients were randomized 1-to-3 to either a low dose or a high dose of KSI-301, 2.5 versus 5 milligrams. All eyes were given 3 monthly loading doses, and then there was a monthly observation period, ultimately through 18 months, during which durability was assessed, and eyes were retreated as needed. So the question was, well, how long will this drug last after you give 3 loading doses? And I'll focus on the wet AMD disease state summary here. And among that population, there was visual acuity gain and CST improvements, as you would expect with an anti-VEGF agent in wet AMD. And then the durability signal was positive. In other words, after 3 loading doses, I'll give you 2 data points for that. So far to date, it's an ongoing phase 1B program. So far to date, 4%, just 4% of eyes require retreatment within the first 3 months after the 3 loading doses. And then on the durability side, beyond 3 months, over 80% of eyes, or 87% of eyes to date, have gone longer than 3 months before needing retreatment after the 3 loading doses. So there appears to be a durability signal there that's real, and because of that signal, a phase 2 pivotal trial called DAZZLE has been written and is now enrolling, looking at the efficacy and durability of KSI-301 in comparison to aflibercept. Aflibercept in this trial is being given on label, which is 3 monthly doses followed by every 8-week dosing through a 1-year primary endpoint, compared to KSI-301, which is being dosed every 12, 16, or 20 weeks, depending on pre-specified disease activity assessments. So just to summarize, we showed new data from the phase 1b ongoing trial here. The data is positive. Critically, the safety signal has been very positive. There have been no cases of drug-related adverse events. There have been no cases of intraocular inflammation across 316 plus doses at this point. So the safety appears a good safety profile, and then the efficacy and durability profiles also look good. But the caveats here are that this is early data, right? This is a phase 1 program, very early data, and we need more robust trial data. And that's why the phase 2 DAZZLE study will be so important to validate these durability signals, to confirm the safety signals, and to really see where this could be placed in our therapeutic armamentarium for wet AMD moving forward.
Will this trial be multi-site or only in your clinic in Houston? Where can patients find more information on getting involved with this new study? Is there anything you'd like to add in closing? Thank you so much. We really appreciate your time.